Hello guys, it's weekend, so welcome to the next episode of Data in Action. I would love to remind you that this series is here because I was tired of listening and reading about what artificial intelligence can do to productivity in the future. So I decided to build the episodes to show what is actually being done with artificial intelligence in the productivity space so far. So in this channel, you only see use cases and case studies that happened, nothing that will happen, because I personally think that we should focus on more what was done with artificial intelligence, and what is going to happen is going to happen. So welcome to the next episode of Data in Action. My name is Alex Kuza. If you like this episode or the previous episodes, please hit subscribe and join the channel and leave your comments. I want to learn from you what can be improved, what can be done better, what can be here, what you guys like. I like case studies that we've done because they show and prove the process of doing artificial intelligence for good and in good direction. So today I found and studied interesting case study for you that comes from this beautiful company that is here. I don't think I need to introduce the brand, pretty well around, from industrial consumer electronic solutions. All my case studies that I'm explaining are publicly available. This one is available on this site. If you put that into Google, you'll find it and you can study that even deeper. So let's look at how artificial intelligence help improving productivity in a warehouse work. This case study was published in the company review by these amazing people. And firstly, please introduce them to you before we jump into the case study. Amazing people from the company. They're working from different departments. First one is research department, Center for Technology, then Intelligent Information Research Department, another person. Also, we have a person here from a Center for Exploratory Research, more practical way. So all of these guys put a lot of work, and thank you guys for publishing that here so we can learn from you. And let's jump into the case. So this is a case study of improving productivity in warehouse network. So those guys were actually tackling very important problem. And I wanna introduce you a little bit to a problem and the context of this for you. So this article describes the development of artificial intelligence driven work system that supports people in their work. That's what everybody says. Augmenting is the future of artificial intelligence, not replacing us humans. We might be replaced to some extent. Part of our work might be replaced by artificial intelligence, but most of their value will come from augmenting our work. And this is the article about that. So these guys were actually looking for the systems that can augment the work, help to make people in a warehouse more productive. So what was the case here? The case here is actually getting a lot of data from the working environment in the warehouse and making a lot of connection between them to see where the improvements can be done. But how the whole process looks like in a company. So if you look at this figure, you can see that there's a process of getting products from a customer and sending products to a customer. Classic warehouse process. Obviously, when we deep into the details, each warehouse is different, but on a general level, it's a pretty simple, it's pretty standard way of how the warehouse operates. So we have a customer, the client that send a work request. And now we have a big data, past performance data, very critical. Those data here are automatically a lot of different input data that comes from the warehouse system. And all of that data are actually explained here in this article, and I'll show you where is it explained right now. If you look here and page 56, you see that KPIs are usually connected to work behaviors like people, locations, things, quantities, and things like this. So we have people in a warehouse, we have locations on the warehouse, we have things that are moving within the warehouse, and there are quantities, qualities, returns, and things like that. And that creates the big data that they actually analyze. And that big data support as a rapid input in the various formats the whole system. And here is when the work is generated, the work instructions. That's a critical thing. The company team realized that if we rebuild work instructions with the help of AI, people can be more efficient. Let's stop me here a little bit and explain what they actually are thinking about that. So they think from the very smart perspective. They say, hey, we have a lot of historical data. If we, and people based on that data get instructions. So for instance, the instructor, they say here is, hey, go in this aisle, pick up this product and send it to this customer. Pretty easy work order. So if we improve the instructions that the employees of the warehouse are getting, we can improve the efficiency. We can increase the productivity. We can influence the productivity. At the beginning, they didn't know if they're going to influence the productivity or not. So derive the work improvement proposals from the data, understand them, and put them in work as an instruction. So work instructions, including derived data and analysis, was actually built for people. And here is a little bit of an icon saying like how people in work were actually instructed. They get where to put the product, how to assemble the package, and things like that. And the product of that was get back again to the AI system to build another recommendation. So that's basically how the company structured the whole process. The critical to understand the whole piece is here, and let me read it. As the importance of the logistics in the distribution industry increases, improving distribution warehouse works is becoming indispensable for maintaining competitiveness. So that's why they improve the warehouse productivity to be more a competitive company. So specifically, shorter work times are needed for work process such as receiving and shipping. And here's the critical thing. Receiving consists of receiving the products from shippers and storing them at the designated location in the warehouse. That's also input data. Shipping consists of receiving orders from stores or individuals and picking up products. That's another part of the equation. So if you look from that perspective, figure 4 actually explain this a little bit, how the configuration of the system was done. And let's look at that carefully here, but I use also the analysis which is described here. So first of all, they read past work results and generates mathematical models of the KPIs and work behaviors. And we can see that actually here. So a lot of data, without the 4 obviously. So here's this one and this one. A lot of data were put into the database to make sure that we have the big picture, that we have a KPIs, very critical thing. They were not doing this just for a purpose. They were doing just for a KPI purpose, which actually narrowed down the proposals picking work in structure improvements. They knew what they want to improve. And if you look at this, you can see here, the built models are used to generate the improvement proposal for a day's work instructions. Imagine how simple that needs to be as a result. The mathematical model is giving instructions that are understood by these people, by these workers, by these employees. That's very fascinating how simple in terms of either understanding and less time consuming it needs to be to get it done. So then they issue picking work instructions. Do you remember when we look at this process here? Picking up is the aim of this test was to reduce the work time spent on picking up. They realized that picking up and the picking up KPIs are critical in the whole results of the process. So they focus the system on issuing picking up work instructions and eventually collect the work results and analyze them as a feedback by the work system and see if the improvement was really done. What kind of data they identified here? Very interesting piece. Numerical values, quantities, dates, times, durations of all activities, orders, categories, IDs, and numbers, codes, and names. So they were actually granulating the data pretty deeply to see which part of the picking up process, which item, what the level of quantity, what kind of codes, times, and things like that needs to be put in place to get that improvement going. And if you look at this graph again, you see what that means to get that results back. and what it means to test it. So work instructions, and the work is done as specified in the work instruction, and the work results are allocated in the WMS system, which is actually here. So this is very interesting case study, how they realize the critical things. Please remember, they know KPIs, they know that picking up process should be improved, not getting the goods. There is not so much they can do probably, I'm assuming this. So the picking up process is more important, and then clear instructions that people need to get so that AI can assist them. Very important. Imagine ChatGPT today. Everybody's playing with it, but if you give employees the clear instructions how to use it, they will be more effective. They have a powerful tool, but then clear instructions needs to be at the end. So what were the results? So first of all, this H refers to the company AI system. Hitachi. H stands for the name of the company AI system. So that's how the acronym they use instead of putting the whole system name. So the picking work times were set as the KPI, and the work attributes of picking work, what was done, how much was done, by whom, when, and where, were set at the work behaviors. Very important. Imagine a tree. If you are coming from a consulting space, it's like a Missy tree. They have a pickup work here, and what was done, how much was done, and by whom, and by where are the work behaviors, which actually stands for Missy, which is mutually exclusive, collectively exhaustive, which means that all of them are complete, comprehensive. That's why they put those factors in work. And figure 6 shows actually the results. But before I go there, I would love to show you this figure 5, congestion and its effect on the work time. They realize also by analyzing which aisle it's actually creating the more work pile. So here we have time, which is affected by the specific aisle, and looking at that traffic and what's happening in the warehouse, they were able to get this. And what is it? The results were actually putting as a histogram here. So what that actually means is, here's number of work operations, and here's time per second. As you can see, picking time was reduced from here to here. You can see how during the control period and trial period, that was pushed back here to around like 20 to 80 seconds per product instead of 100 on 124, which stands for work time reduced of averagely 80%. I love this case study. This is where artificial intelligence was put to work to get the results, and it was done and tested and published by the company as the result. Those amazing people put a lot of work, a lot of credentials to them for publishing that, so we can study and learn from them. So the wrap up from me is here. Please remember that, first of all, a lot of historical data is needed. Second of all, the comprehensive process is needed, and understand when the improvement should be done. In this case was picking up space, the KPIs in this part. Then clear instructions to people, and then actually attack a specific KPI, which is time. And in this case, they reduced that by 8%. And I hope you like this case study. If you want to study it more, please remember it's published on a company website, case study of improving productivity in the warehouse, real case of AI, written by these amazing people from Hitachi. So thank you so much, guys. I hope you enjoy it. Have a great day. If you like this, please subscribe to my channel. Follow that. Data in Action is published every weekend. Only what was done in productivity and AI space. Take care. Thank you. Bye-bye.